Hello guys, welcome to my channel Sahaj Gyan, where we try to learn by building our intuition. Today, we will talk about one of the most fundamental topics in physics, motion, which is the foundation of classical mechanics. When we say that the object is in motion, we intuitively mean that the object is changing its position with respect to time. In other words, the object is moving or the object is not at rest. When the object moves, it can follow multiple paths. When we drop an object from a height, it follows a straight line path, and this is called a straight line motion. When we rotate a ball connected to a thread, it follows a circular path, and this motion is called circular motion. When we see a person on the swing, he follows to and fro periodic motion. This is also called periodic motion. When we see the motion of a mosquito or a honeybee, we see it's just moving randomly, and this is called random motion. In this chapter motion, we will study straight line motion that will build our foundation to understand more complex type of motions. We will try to understand motions from three equations of motion, and we will also interpret motion graphically through a distance or a displacement time graph and speed or a velocity time graph. Let's deep dive into one of the most fundamental attribute of motion called position. To measure a position, we need a reference point. The reference point is sometimes also called as origin. In a cricket field, the boundary is measured with respect to a batsman. So we can say that the batsman position is origin when we measure the boundaries of a cricket field. If the position of the object with respect to the reference point do not change with time, we say that the object is at rest. Alternatively, if the position of the object with respect to a reference point changes with time, we say that the object is in motion or the object is moving. Here, it is very important to note that the object and the reference point are in the same frame of reference. Generally, the ground is considered as a frame of reference. It is true in most cases, but not all the cases. Let's try to understand this with few examples. If you measure the position of a train with respect to a stationary person on the platform, we can say that the train is moving with respect to the person. Here the person is the reference point and the train is the moving object. Let's consider another situation where two persons are sitting in a moving train. Here the person sitting in the front, let's consider his position as a reference point. Now we can ask two fundamental questions. Is the person sitting in the back moving, is in motion? Of course not. But this happens only when we consider train as a frame of reference and the person sitting in the front as the reference point. So with respect to the reference point, the person sitting in the back is at a constant distance. So the person sitting in the back is at rest with respect to the person sitting in the front in the train's frame of reference. However, it is not difficult to imagine that the both persons sitting in the train are in motion with respect to a stationary person on the platform. Here, the stationary person's position is the reference point and the ground is the frame of reference. So, it is very important to note that the reference point should be in the inertial frame of reference. In first example, the reference point, the person standing on the platform, is in the inertial frame of reference called ground. In the second example, the person sitting in the front on the train is the reference point, which is in the inertial frame of reference, that is the train. We can extend the same argument to two persons moving up in the lift. In this case, two persons are at rest with respect to lift as a frame of reference and a reference point within the lift. However, those two people are in motion with respect to a stationary observer on the ground if you consider ground as the frame of reference. With this, we conclude the first part of the motion where we focused on one fundamental attribute called position. We described position of an object with respect to a reference point in the plane of reference. If the object moves with respect to the reference point in a plane of reference, we say that the object is in motion. In the following videos, we will study about other attributes of motion called distance or displacement, velocity, and acceleration. See you in the next video.